All right. Let's get busy. So, um, I'm pretty tired, but of course I do want to do this, so let's just get busy with it. Let's ring it up. Okay. So, here, let me just, kind of do the tour of what I am thinking. So, first of all, here's the site, and, okay, whatever I just hit, it wasn't right. Okay, so here's the site. Um, and I think it should show that it started the world boss. So let's take a look at that, I guess, first, since it shows that. Here we go. Okay. So for the world boss, all the players are supposed to come and, oh, this is like the flavor text. I don't know if it's flavor text. It's this whole thing. I don't know. I'm not trying to read that. But, yeah, so everybody who, I don't know, just basically participates on the site, gets some XP, and contributes, I guess, to defeating the world boss. All right. Um, so for me, like, I think it probably says, so like you have to gain 5,000 XP to earn a chest on the world boss or whatever, right? So, oh, did that open in a new tab? There we go. So we can earn some XP without resetting, probably. For example, like, it looks like there's, like, I could just mark these complete, basically, with whatever GitHub project that I would want to put in there. There's a few open here. I could mark these complete, but it's probably not 5,000 XP worth. Actually, it might be. But either way, what I told myself is I'm probably gonna just restart. Um, but I'm having second thoughts now because it just seems kind of dumb. So what I put down in the title to do computer science basics, like it would be pretty basic. The idea would be restart and just start from here, from the beginning. And then the idea would be it's going to say, welcome to Fantasy Quest. And then what we would do is we would kind of in parallel do all these things in C++ as well. So I guess I would go projects, boot dev, and then I would just like, let's say we create CPP, and then um, we would do this, like, and I guess I would just call this one basics, and then in basics, I guess I would make just, so this is just like a really hello worldy, just print welcome to Fantasy Quest, right? So let's see, so maybe I'd just say let's make introduction, and then this one is just welcome, and that's the only one that would be welcome, right? And I would probably skip these challenges too. So I don't know. I'm kind of warming to the idea. I don't want to jump in if it's gonna be super dumb necessarily, but okay. So let's say that I'm here in welcome, and then I just want to make like welcome CPP, I guess. Okay, so let's take a look. So let's hash include um, IOStream, and then let's say int main, and then let's see out trying to see how much I actually remember of C++. I mean, this is really basic, obviously. So welcome to Fantasy Quest. I seem to remember some of this. And then I guess that's it. And what's this say here? IOStream file not found. Okay, well, I'm not sure about that. But if I try to like GPP, do I just do this? No, not found. Did you mean standard? Ah, yes, I think I did. I think I did. And is it this as well? Well, actually, let's see. Yeah. So it says relocation in read-only section dot text, undefined reference to standard C out. Why is that? Undefined reference to standard C out. User bin LD. Undefined reference to the operator. I think we can also always say like using namespace, right? Right? Which maybe I actually do prefer to do in this case, I'm not sure. But let's see what it says that's different if we do that. Yeah, it still says the same thing, I believe, right? Undefined reference to standard C out. Okay, so let's look it up real quick. Obviously, there's something that I've forgotten that you need to do in terms of setup. I may need a .h file. I'm not sure because I just haven't practiced with this in a long time. So yeah, we're using G++ is what it is. Well, that would be a good start probably. Okay, so that says good, I guess, maybe. So what did it build? It built an a.out. And now it says the phrase. Okay, so if we want to just maybe like, let's see. So we can do -o, place the output into the file. So that would be something other than a.out, presumably. What else? Let's look. Getting started with G++. I mean, I guess I already really have gotten started with it, which I'm thinking I feel good about. So typed in the source code. I used Vim, by the way. Anyway, so let's see. Okay, so we figured this out instead of GCC. I tried GPP at first, I don't know. All right, so then there was a out. All right. And so, yeah, okay. I guess that's a good for getting started. So G++, let's say the dash O, I'm just gonna call it out instead of a dot out, I think. And then no, no input files. Oh, G++ dot, no. Okay, so that's what I'm gonna say. So let's echo that into main, or yeah, sure, main sh, and then okay, so there we go. So now I think that's how I want it. Okay, so I've got the main.sh. Let's get rid of the a.out, or yeah. Okay, so that's how I would get started. I feel good about that concept, I think. So here, so let's take a look around the site. I just want to look at a few things. So first of all, I have this pretty good streak. Like if I reset this and submit that, it says okay. I mean, this is just the welcome, right? And so the streak is pretty good. So in terms of like achievements, there's an achievement for getting up to 144, and so I'm pretty close to that. I've got a good amount of items here, basically, like in the item shop. This is a pretty good amount of items. These are all my lessons completed, 2100 lessons completed, and number of sharpshooter streaks or sprees, whatever they call it. Like there's an achievement for that as well. So it's all gamified, like sharpshooter grandmaster, right there. And then like if I go into my profile self, then I'm level 150, which makes me number 1 in the leaderboard rank. And it shows all of these certificates for having done things. And actually, I think they updated these. Yeah, check it out. Some of these, yeah, like HTTP clients need these say the language now, and so here's like what the certificate looks like, I guess. So anyway, I think that if I reset in order to gain more XP to participate in the world boss, I think more or less a lot of this goes away if I do that. I'm guessing this streak probably would reset. This would certainly reset, I think. Pretty sure this would reset. I think I'd probably lose all the items. I don't know if I lose the certificates, but I'm guessing perhaps yes. But I think I'm just gonna go for it. Like, it doesn't really matter. Right? And like if I feel like I'm gonna get something out of this by doing all the content in C++, like I don't think it's gonna take me forever to go through the content by any means for a second time. And this time, like, here, let's look again. So this one's in Python. Um, Shells and terminals. Honestly, it might. This is probably not very worth it to redo it at all. Learn Git. Most of these probably aren't very worth it to redo it. But I kind of do want to have at least like the VODs for my own future perusal or whatever. And doing all of these in C++ would be nice, just to be like, okay, so now I have sort of this foundation in C++. But like a lot of these are not even going to be in C++. Like this one, CI/CD, it's not really going to have anything to do with any particular programming language. Docker either. So here I would do these in C++. SQL, that's not going to be C++. This one will be, this one will be, this one will be, this one will be. This one, yeah, you can do that one in C++ as well as C, totally. This one, you can do this one, this one, this one, this one, this. Yeah, you can, yeah, so most of these. And then I probably won't even worry about, like, these that I've done. Now, a couple of these would be good for me, I think, to do again. Especially Kubernetes. I went through that and it just went almost in one ear out the other because it's like try all these different commands and YAML files, and I tried it, but I don't think I really absorbed that much. Anyway, so having kind of gone through all this, I'm gonna try to find the big reset. Reset all progress. Okay, so this is gonna be the current level should go back to 0 or to 1, whichever it starts with. I think probably 1. XP goes back to 0, completed lessons to 0. Yeah, and even the certificates. So if you'd like to keep your certificates, please download them before resetting. This action cannot be undone. Okay, so let's see. I think, would I like, you know what? Yeah, I don't really care. Let's just go ahead and do it. Reset all progress. So is there anything that I keep? Probably just the warm and fuzzy feeling of knowing that I had the things before. All right, let's confirm. Okay, so we're back to 0. So enter course. So now we're participating in the world boss. So everything is zeroed out. That's crazy. All right, so I'm just gonna submit this one. Oh my gosh. Okay, so achievements popped for having karma in the Discord because that didn't reset to 0. The Discord is not, like, it's connected to the account, but it didn't reset. And so it looks like did these achievements drop some XP? Because it looks like I got, 314. Okay, achievement unlocked for karma in the Discord. Achievement here. Achievement here, okay. Achievement here, sure. And achievement here, fine. All right, cool. So then, let's see what else we want to do here. So let's go to quest and accept the 5k XP chest. Or quest. Chest quest. Yeah, so now we're starting to participate. We've got 314 so far. All right, anything else we need to look at? So let's look. So welcome to Python, the best first programming language. In my opinion, this is fine. Many people say that Python is the best first programming language. Certainly it's an excellent one. But if I personally were to pick a best first programming language, I would say for most people, probably C++, actually. Now, the thing that Python has over C++ is that it has far fewer footgun type problems compared to C++, right? But they're both good. So how to run code on boot.dev. So the grayish blue run button runs your code, okay? I don't, is this grayish blue and the golden submit? I guess that's a grayish blue. The golden submit button runs your code and submits it to check your work. And notice we do have hotkeys. So Control Enter, Control Enter, and Control Shift Enter. Run it. Okay, so then, and then the right arrow will take you to the next lesson, and that's up here, and that's Control Dot. So Control Dot to go forward lessons, and Control Comma to go back lessons. Control Comma right there. So, building Fantasy Quest. We're going to build a text-based adventure game called Fantasy Quest in this course. I've written the first line of code for you. It prints a message below the editor welcoming new players to the game. Great. And submit the code to pass this assignment. Then click the dash arrow, right arrow. Okay. All right, I'm being dumb. I do feel kind of tired, so I'm going to go through this a little bit slow, probably. I do think that I'm probably going to commit this stuff to a Git repo, and I think I'm gonna commit basics. So I'm gonna git init at this level, and let's see, status. So it shows that the introduction is there, and we can add everything, but I don't want to add my binary file, right? Actually, what is the size of my binary file? Okay, so here's what I've got so far. I've got the Git. My binary file size is 16 KB. Yeah, that's not bad. That's not bad at all, I don't think. But in any case, yeah, I don't want to necessarily commit the binary file at all. So I'm going to say echo out to my git ignore. Okay, so I'm going to add. So we added the git ignore, the main sh, and the welcome CPP. So I'm going to say commit, and I'm just going to call that init commit. And I'm just going to put that on my GitHub because why not? I guess the reason why not would be because it's kind of dumb, but whatever, I'm fine with it. So I'm just going to hit new repo. It's going to be called basics, and I will create, and then let's copy that and put that right in there. Oh, unable to access. Okay. Oh, okay. So I'm going to add myself as a collaborator. Oh, gotta use my authentication code. Which is this one. Okay. And then let's add a collaborator, which will be I think I used dashes, and I was always unsure. Okay, so let's invite. And then I'll switch account. Is it this? You know, I don't think I have the password for that. Because it's not that one. So I'm going to say forgot. There's my email. I'm going to verify. Okay, so use the arrow. Okay. Oops. Sure. All right. Let's take a look here. Reset your password. Okay, I'm just going to do kind of a simple password here. Oops, I think I mistyped it. I'm putting it in on my phone. Okay, it says new password set successfully. So let's try it. Okay, switch. Okay, let's sign in there. Nope. Darn. Huh. Well, I thought I was good. It says your password was reset. Okay, so did I mess up resetting it? Maybe I just put it in wrong here. Let's try one more time. Nope. I guess I'll reset again. I don't know. Try it one more time. Okay. All right. So maybe I'm gonna try the same one that I put before. I don't know if it'll let me. Says set. All right, sign in. Okay, so switch. So maybe I need to use that email address again. Let's try it. Okay, cool. Let's see what code it sent. All right. Okay, so let's go ahead and do that since it says I have to. Okay, we'll scan the QR code. Okay. And all right, so now I'll put the number in. All right. And yeah, do I need a pass key, a security key, a GitHub mobile? No, I'm good. All right, so now let me go and accept the invite. Okay, so now I should be able to commit. I'm gonna go back to the other account though. All right. Any luck? Okay, so now we're good. All right, all right. So we have a C++ code in there, and can we take a look at it? Hooray! So here is this. Now, of course, we notice C++, you know, it's an older language, it's an object-oriented programming language, and like most of the big OOP languages, it's a little verbose. Certainly, it's not as simple as just saying print welcome to Fantasy Quest like we do in a nice scripting language like Python. Instead, we include some of this boilerplate, but whatever, it's fun. So let's go to the next. So let's see, did we read all this? Yeah. Okay, let me just try one more thing before moving on. So the LLM guy here, in fact, does this explain something? Boots a wizard bear that codes. So it's a chat GPT like interface, basically. So we can say, hi, Boots the Magnificent. Don't you, and this is the only time I'm going to do this, but don't you agree with me that while Python is undoubtedly the second best first programming language, surely the real best must be the inimitable C++. So it says, my young apprentice, every programming language has its charms and purpose, much like different ingredients in a wizard's potion. Python is renowned for its simplicity and readability, making it a friendly first language for many newcomers. It allows them to focus more on learning core programming concepts and less on intricate syntax. Oh, yeah, yeah, that's pretty much exactly what I was just saying, right? Oh, look, we have this boilerplate. What the heck? C++, on the other hand, has its own set of enchantments, offering power and control particularly suited for performance-critical applications. Oh, that sounds fun. It introduces concepts like memory management and object-oriented programming. That's what I was just saying, right? It's a OOP thing, which can be enlightening to experienced mages. So tell me, what do you find about C++? What do you find most enchanting about C++ compared to Python? All right, I'm not going to answer that. Let's go to the next one. Fix your first bug. So, the combat system in Fantasy Quest is not working as intended. It appears that players are gaining health when attacking instead of losing it. Fix the math bug on line 3. Okay, so I'm just going to copy this. Can we... Wait a minute. I thought Control A would copy everything. No luck. Okay, copy. So, this whole concept is seeming pretty dumb, but whatever. So where are we going to go? So we're still in introduction. We're going to make, so welcome, and then let's make first bug. Okay. So then let's do the first bug CPP, I guess, right here. I'm just going to paste that in there. So we know, of course, Python code won't work in CPP like this, but it's okay. Let's just make it. So let's include our IO stream again, since we see there's prints. Let's use the namespace again, why not? And then let's do int main, sure. Let's indent here, sure. Invalid pre-processing directive, no doubt, no doubt. Don't touch below this line. Okay, so we're here where we have print. Let's not do print. Let's say print yeah, let's replace that part and say cout and put these things. Okay, it's a decent start. And then I'm gonna say, so do we want, we could do like a printf. In this case, I think I'm just gonna use a regular concatenation. Oh, except if we do that, can we concatenate an int to a string? I don't remember if that's technically allowed. So I'm gonna find out. It might be. I'm guessing probably not. Oh, wait. I think what we do is we do this. I'm not sure I ever learned what that operator is called. C++. So it's called a left shift, but why is it used with cout? Right? Like it's overloaded for cout. Does that seem weird? OF stream. Okay. So we'll do player health. I feel like I'm just doing slow, dumb stuff for no reason, honestly. But yeah, I think if we use this thing, it might be okay, actually. So health is that. Wait, why is there? Oh, that paren does not belong. Should be like that. And then like this. And then here. Undeclared, I think that should be okay. So then here we'll just say this is going to be, whoops, int. See, it's pretty similar. And then here we'll say int k. So then this one, what does it say? Using directive refers to implicitly defined namespace std. I think that should be okay so far. So then let's go ahead here. Fix the bug where addition was used instead of subtraction. But first, let me just see if what we've got so far will work. So G++, so this will be echo this, it will be first bug this time, to out, and let's put that into our main sh, and of course do this, and it says, okay, oh, I've got a spare, oh gosh. I've got a, yeah, I don't want this. Okay, is 100, hit by a sword for 10 damage, now 110. Okay, so we know that that's wrong. So let's go ahead and fix the bug. And if we run it again, it goes down to 90. So that's good. So I'm going to say first bug fix. All right. I guess that's good. Okay, so let's see. Oh, let me back on my phone. Yeah. All right. So that sort of got us started. So, I mean, obviously this is the simple stuff. So the combat system in Fantasy Quest isn't working as intended. It appears that players are gaining health when attacking instead of losing it. All right, so that's pretty messed up. So we'll just press run and, oh no, that's not, what is it? Okay, run. Setting up your environment. Really? Really? Let me just refresh. Okay, so let's run. Okay, oh, I hit submit when I really shouldn't have. So we want run. Okay. Okay, so run and submit. Okay, that's fine. So let's go to next. And so it leveled us up, so we can see like the first levels, the early levels are real easy to gain, just like 480 XP for a level. And we saw that like the exercise, the simple exercise, like paid out quite a bit of XP. So anyway, so we'll print this text to the console. Right? So that's all we have to do there. And again, I mean, it's super fast to go through this, or potentially. So fix the math bug was this. So the console is a panel that displays important messages like errors or the text output of a program. If we want to see what's happening in our code, we need to print it to the console by using the print function. So we'll learn more about functions later, but for now, just know that the print function will print anything you put inside its parentheses. For example, print, and then it says, this is some example text to print, and so whatever. So we run this, and then that's fine, and we submit, and it says correct. Okay, so So if we're following along here, we want to come back and make a console dir. Honestly, these could probably be all in the same directory. I'll just stick to it the way it is now. So we'll go into console. We'll say console cpp. We'll put in our boilerplate again, I guess. I'm gonna say this still. We'll say cout. We'll put the text, just do like that, and then yeah, so we'll do this. Let's just call it console this time. Chmod. Use the arrow keys to move. Okay, so the console. So we'll push that. So we're just basically following along with exactly what we're doing in the course, just in a different programming language. Because why? Because we just feel like Python is for, I don't know, people who like AI or data science or soy devs or something like that. And C++ is for cool people, I guess. I don't know. That's the idea. It's for cool people. That's all. That's all I know. All right. So here we go. So what is Python? What is Python? All right. So thousands of students start their coding journey right here with Python. We think it's the best programming language to get started with. Python is famous for being a simple language that's easy to read and write. However, just because it's simple, that doesn't mean it's not useful. Python is an extremely popular language in the industry and is well known for backend web servers, DevOps and cloud engineering, machine learning, scripting and automation, etc. On the other hand, it's not particularly well known for front-end work. While it's possible to do so, Python isn't typically used to build visual user interfaces. All right, and there's a video apparently, not going to worry about that. So we're just going to say not often used. So is it often used in machine learning? 100%. Backend servers, absolutely. Automation scripts, also very common. Front-end apps, not so much. Okay, so that's fair. Let's go to the next. Python is known for being simple or complex to read and write. Okay, so it's simple. And that is like simple compared to things like C++. Okay, oh, achievement for completing 5 exercises. That's kind of neat, I guess. Let's take a look. Achievement, milestone bronze, complete 5 exercises. 97.71% of students have earned this achievement. That's great. Okay, oh, and there's an explain button. I'm not going to hit that. All right, let's move on. Okay, so what is quote-unquote code? All right, code is just a series of instructions that computers can follow. Computers obey each instruction one after another. Programs can be comprised of many instructions, like many, like millions. Addition is one of the most common instructions in coding. All right, so here they print 1 plus 2, and of course we're totally able to do that, and we see that it says 3. Great. So remember how we used the print syntax to print some text to the console? We can also use it to print numbers. All right, so here's another one. 42, and we can also add things together. I guess we already saw that, but whatever. So there we go. It first calculates the sum inside the parentheses and then prints the result. So assignment. Basic addition is everywhere in video games. For example, we may need to deal bonus damage when a sword is enchanted with a power spell. Our hero's sword deals 250 damage normally, but should deal an additional 75 damage when it's enchanted. Calculate and print the result of 250 plus 75. Okay. $250 plus 75. Okay, so we get a 325. That's all it wants, right? Okay, so let's go ahead and just put that into here because I'm falling. I don't know. I don't know if I'm being like too silly or too like what might be the word. So this one is called code. I don't know if I'm being too like rigid, but whatever. So let's include our IO stream because we're going to print again using namespace. Oh, you know, something else I could do would be to include tests for these things because they obviously have a test that is running when we submit, right? Um, yeah. So I'm gonna put just 250 plus 75. And then let's do this again. This time I called it code. Uh-oh. Couldn't deduce. Okay, so we couldn't do it like this, right? Oh no. Okay, so I think it's complaining that like the type couldn't really be inferred from what we did there. So let's just do it again. So we'll say int a equals 250, int b equals 75. If we do it like this, then maybe it won't complain. I think it's a type inference problem. Like it couldn't infer types the way we were doing it before, probably. Let's see. Nope, it's still got a problem here. Pretty verbose output too. My goodness gracious. All right. Oh, I have an end instead of an end L. Maybe that was the problem all along. Okay, let me go back. Yeah, you're not supposed to just put things willy-nilly. Okay, so it was fine. It was just end. Man, it was sure a verbose, crazy output. But I mean, it said the exact thing. Standard N unresolved overloaded function type. So it's, yeah, it's something completely different. Anyway, let's move on. So all right, let's go to the next. So we got this. All right, cool. Let's do the next. So multiple instructions. Code runs in order, starting at the top of the program. For example, print this prints first, print this prints second, and print this prints last. So each print instruction prints on a new line. Very convenient. The dialogue in our game needs to be printed in the correct order. In the first level, our hero encounters a talking owl named Jax. Let's display their conversation to the user through text. Rearrange the code so that it prints in the following order. Jax, be caw, hero, ... Where are you off to this morning? Be caw. Where did an owl learn to speak? I thought owls said hoot. What is be caw? Alright, it's fine. So we'll say that first. Oh, okay, so we just had to move that one. All right, that is fine. So let's copy this. Multiple instructions. All right. Include IOStream. Okay. Then let's go. So this one will be called I put end again. Okay. Just the one place though. Beacaw, where are you off to this morning, Beacaw? Where did an owl learn to speak? Okay, fair enough. All right. I don't know if I don't know if there's any point to this. I'm just gonna keep going. Like I said, I'm kind of tired. I'm okay with running through kind of slow, I guess. So, multiple instructions, cool, cool. So let's go to the next. It says syntax errors. So syntax is jargon for valid code that the computer can understand. For example, the following code is invalid syntax. All right, so can you, I don't know if we can see, but we mismatched the quotation marks, right? We used a double quote here, and we used a single quote here. In Python, either one is technically allowed, but you can't mix them like that. You have to match a double with a double or a single with a single. So this code is incorrect because it uses mismatched quotes around the string hello world. Similarly here, we see that we mismatched braces. So to call print, you always have to use round braces. The square braces are for like things with lists usually in Python. So there's a bug in our game. Our players are getting mad, or like you can use square brackets in like if you're indexing a dict in Python, that's common, but we can't use it here. There's a bug in our game. Our players are getting mad because they pay us $20 per month to have access to Fantasy Quest. Read the syntax error in the code that's in the code editor, not the code above, and correct it. Okay, that's fine. So we'll just fix that real quick. So if it's like this, then it's going to say, oh, hey, it's not help, syntax error, we don't know what to do, right? So Python, like, it's not designed to know what to do if you make a mistake like that, obviously. So we can go ahead and submit that one. That's fine. We gained 304 XP. And so 1% daily streak, apparently, for having one in the day streak. Okay. All right, that's cool. That's cool. So this is literally the same thing that I already have. So I'm gonna just copy it. Syntax errors. And I'm going to CP. Wait, where am I? I'm in introduction. Okay, I'm not supposed to be in introduction. Let me move some things. Oh wait, yeah, I am supposed to be in introduction. But am I missing something? Okay, so I have welcome, I have first bug, and I have console. Okay. Something not where it belongs. Multiple instructions and syntax errors should be moved out of console. Oh no, it's not R. It is... So we can use a directory if it's -t? No. My brain is like Swiss cheese. MV directory. So it is, wait a minute. Remove the target and, okay. So we don't have to do anything special? Okay. All right, well, if we don't have if we don't have to do anything special, then no wonder I didn't remember what special thing to do. Does that look flatter now? Yes, but there's nothing in syntax errors yet because we are going to copy we're going to copy that file to syntax errors. Okay, so then in syntax errors, we're going to echo, and again, this will be called syntax errors. So it says, welcome to Fantasy Quest. Oops. Okay, so we just did syntax errors, but let's okay, so let's go to the next. Okay, so we're good here. Syntax errors quiz. So syntax in programming are the rules that define what properly structured expressions and statements look like in that language. For example, in Python, the following would be considered correct syntax. Okay, so we go print hello world. Okay, fun. While in a different programming language like Go, the correct syntax would be format.println hello world. Okay, so we've been seeing that. It's not the same in every programming language, and we've been seeing what it is in C++. Okay, so code can have many different problems that prevent it from working as intended. Some examples include a bug in the logic. For example, a program that should add numbers together, but instead multiplies them. A problem with speed. A program that calculates how to play the perfect game of chess might never be able to finish it because it requires too many calculations. Well, that's pretty messed up. Okay. And a problem with syntax. So this is the most common problem for new developers. Luckily, the Python interpreter will try to give you a descriptive error message in the console to help you find the problem. Okay, and we link to a definition here. That's fine. All right, so what does syntax mean? The rules for valid code in a programming language. Cool. Does it mean fast code? No, that would be like, I don't know, efficient, performant, something like that, but not syntax. Code that produces the correct output? No, that's just correct. Code in the browser? That is called JavaScript. Or WASM. All right, so we'll just choose this one. Okay, what happens if you try to run code with invalid syntax? It doesn't work. The computer doesn't freeze, the network doesn't disconnect, it just says syntax error. So it won't work, but it's no big deal. All right, let's go to the next. Oh, so I am going to choose to skip the optional challenges for now. All right, so now we're going to do variables. How are we coming along on the quest? 39%? Yeah, we'll keep going. It's fine. Okay, so what is this? Where did this lead us? Users.cs.utah.edu, topics, variables. Okay, so this is from some college course, I guess. That's cool. Let's just close that. Variables are how we store data in our program. So far, we've been directly printing data by passing it directly into the print function. Now we are going to learn to save the data in variables so we can use and change it before we need to print it. A variable is a name that we define that will point to some data. For example, I could define a new variable called myHeight and set its value to 100. I could also define a variable called myName and set it equal to Lane. Okay. Creating variables. To create a new variable in Python, we use the following syntax. Okay, so we say my new variable 2, so we use a name here. The name can't have any spaces in it, so they used underscores instead. Then they used an equals sign here, and then they put the data here. This can be called anything equals 3. Okay, cool. So we need to keep track of our hero's health. On the first line of code, create a new variable named player health and set it equal to 1000. So it says don't touch below this line, and so they're going to print that. So first, before we try to print that, we want to say player health equals, and we're just going to put 1000, I guess. 1000, there we go. So there we see the 1000, and we can go ahead and submit that. That's fine. So let's go ahead and again do this. So this is called variables. So let's do variables. And let's do variables CPP. Paste that. And we're going to print, so let's use our friend, the IOStream, which is very nice. Let's say using, and let's put these into our int main function, right? Okay, so this one, oh, whoops. Okay, so this one, so here we have to say that it's an int. That's a little bit different than Python. And sure, that's pretty much it. So save that, echo, and this one will be called variables. And there's our 1000, so that's fine. Yes, let's, so this one is called variables. All right, works for me, baby. Let's go to the next. Variables vary. Variables are called quote-unquote variables because they can hold any value and that value can change. It varies. Well, so for example, the following will print 20. So we said the acceleration equals 10, but then we said it equals 20. Okay, so we changed our mind and then we printed and we got 20. So the 10 is no longer like, it just no longer exists. We basically effectively got rid of it. So here, yeah, reassigns, it overwrites whatever was being held in the acceleration variable before. Now I say it gets rid of it. In Python, from what I understand, that's technically not true. Like, integers like this, they all sort of just exist, and like every variable that that is assigned to 10, I read about this quite a long time ago. In Python, every variable that is assigned to a 10 is actually holding a reference to the same 10 that exists, I think. So that's kind of funny, if true. I think that's true. I remember doing some tests with it, and it was kind of funny to see. In fact, let's just look it up real quick. In Python, every variable with an int references the same instance of that int. So this is python.org. So you can put an ID, and it says wait a minute. Oh, so that's not true. When called a tuple/list, we do not get the same objects. Why? So integers are not mutable. Code that cares about the ID of objects is usually wrong-headed. Okay. We're just curious, right? We're just curious. So we have some IDs for these numbers. The ID, wait. Do we need to, this is a little bit different from what I actually want to be into right now, but let's go ahead and just read it since I'm here. Integers are not mutable. The short answer to every question like this is that there are not any useful guarantees, and the code that cares about the ID of objects is usually wrong-headed. If you have mutable objects, then you will need to care about whether they are getting shared between two different places. Sometimes it's a good idea to share them deliberately. Sometimes there must be separate objects so that they can update separately. But in a large amount of cases it won't matter, especially if you won't actually mutate the objects. The exact results will depend on the implementation details. In CPython, it has been like this as far as I can recall, but as far as I know, there is no guarantee of it staying this way, since 50,000 is not one of these small integers that get cached ahead of time. So this is the concept that I was actually looking to look up. This concept of small integers that get cached ahead of time. But in any case, for this one, each separate line that says ID 50,000 would create an object for the 50,000 integer, figure out its ID, the address of the object in memory, keep in mind that this is virtual from the operating system, and then throw both things away afterwards. Okay, so he said ID 50,000, cool, but if we do this, so if we're in Python and we do the same thing that they did, ID 50,000, okay, so we can do that, then we can do it again. Oh, it is the same number, so it did not get garbage collected. But there's no guarantee of whether it'll get garbage collected or not, right? That's what we're basically saying here. If we used maybe a larger number, would that make a difference? Oh, wait a minute. It's the same thing. What the heck? So I think we can like count references to an object. That's what I remember doing before. Python count references to object. So there is, so we'll say from sys import get ref count get ref count 0, 401. 231 to 1. So these small integers, there's a bunch of references to them, right? But a big integer like z, we've only got a couple references to it. How many do we have? 2 minus 1? Yeah. So basically, somewhere within the runtime, there are 401 different references to the number 0, but they're all referencing the same object, is my understanding. Do we want to read anything else from what was being said here? Okay, so if you do this several times in a row, normally the results will be the same. Okay, that's what we saw. So the reason is that after each line is done and the memory is cleaned up, the overall structure of the memory, which addresses are in use, is the same. Therefore, when Python tries to allocate memory for the next integer, the operating system will probably tell it to use the same part of the memory that it used last time. Okay, so we did see that, right? It may do this because the previous integer was freed. It doesn't exist anymore. Right? So that's where we saw I got the same thing when I did 50,000. I got some ID here. Then I did 5 million, and it came out with the same thing. I was like, oh, wait, why? But this guy tells us why, so that's wonderful. So the same thing happens in a line like ID 50,000, ID 50,000, ID 50,000. So we have a tuple here. Let's put this into our console as well. Okay, so do we see the same thing coming out 3 times? Yeah, and why not? It's the same number 3 times. Each 50,000 doesn't have to exist anymore after ID was called on it. Only the objects for the ID results need to stay around. But those results can be separate integer objects even though they have the same value. Okay, so then, so what if they're different numbers? So if this one's, so if we do that, then, so, okay, so this time they are different. So wait a minute. So that doesn't seem like it's quote unquote the same thing, because this time I put these IDs into a tuple, but now it's 3 different IDs because they're different numbers, right? Whereas if we were to do ID 50,000 like this, right, and then do 60,000, is it going to be a different number or is it going to be the same number? It's the same. And it's the same again. But when we did them all in a row, we got 3 different ones. So I'm not sure. So it's not the same thing, right? But let's hear them out. So each 50,000 doesn't have to exist anymore after ID was called on it. Only the objects for the ID results need to stay around. But those results can be separate integer objects even though they have the same value. For example, I just got, so we have a list, XY, with the ID twice, and they have the same value here. But they are separate objects. Oh, that's wild. Okay, so let's try what we did here. So XY, we're going to make that into a list. Okay. So we put 2, okay, yeah. So we put 2 IDs in there, and they are to the same place, same number, sure. But the ID of that number is something completely different. Okay. That's crazy. So XY sub 0. So this one, so if we put the ID of this, then we do 048. Oh my gosh. So even though these are both the same number, we have 2 different objects of the same number. And he explained why, but I don't think I get it. So they can be separate integer objects even though they have the same value. If we directly put the same integer into the list, though, Python can tell ahead of time that it's the same integer and reuse it. It couldn't do this in the other version because when Python figures out the code for building a list, it doesn't consider what the ID function will do. Yeah, okay, well, why would it? It has to assume that ID could give something different every time, even for the same input. After all, that's exactly what happens if you use For example, rand int from random. Okay, so wonderful. So that was a tangent, and I'm happy to look at it, but let's move on. So variables vary. So did we go over this? The line acceleration equals 20 reassigns the value of acceleration to 20. It overwrites whatever was being held in the acceleration variable before. Okay, so we need to reduce our hero's health as they take damage in the game. Okay, so what happens when we run what we've got? I've got 1,000 4 different times. So we do player health equals 1,000, and we print it, and we print it, and we print it, and we print it. Okay, very fun. So before each print function in the provided code, change the value of player health to 100 less than it was before. Okay, that's fine by me. So we'll go ahead and just put player health subtract equals 100, right? Should be fine, and we'll put it there. Oops. So we got 900, 800, 700, 600, and that's what it's supposed to look like. Okay, so let's copy this. So this is going to be variables vary. Okay. So I'm going to paste this in here. And so we're printing again, so let's have our friendly IOStream again. Let's use this namespace. Just figure, I don't know, I like to, I guess. Okay. Here, let's... So if we have a hash and, then let's make that... Yeah? Okay. Player health. Okay. So then when we have print, let's say that that is going to be cout. Okay. And then wherever we have that close or player health parenthesis, let's make it player health and do like that. Put a semicolon. We do need semicolons. And yeah. So this is complaining about this, the undeclared identifier. So this is from Clang D, apparently. I don't know if that's right. That's probably something I should look into fixing or something. Let's see. Okay, let's just do this first. So we'll echo. So this one is called variables vary. Let's chmod. Okay, 900. So same as we had before. Sure, let's commit. Variables vary. Okay, so that's fine. Okay, so yeah, let me go in here again. So is it complaining about cout or is it okay? I guess it's okay now. In that case, I think I won't worry about it. Okay, Let's go to the next. Let's do some math. Now that we know how to store and change the value of variables, let's do some math. All right, let's do it. Here are some examples of common mathematical operators in Python syntax, okay? So we can do a sum with a plus, a difference with a minus, a product with a star, and a quotient with a slash. Amazing. Create a new variable. Should we call this a dash? A plus, a dash, a star, a slash. Create a new variable called armored health. Oh, you know what? You know something? I know so in American, I usually call this a dash, and I usually call this a slash. But I know in Great Britain, I think that the terminology is quite different, and I think maybe, is this called a dash? I don't remember. Hold on, let me look that up. Dash and slash typography in American English versus UK English. Okay, let's see what it says. So in US English, wait a minute. Show results with slash. Here we go. Okay, backslash, so known as a stroke, solidus, or forward slash, known as the oblique. Variant form of dashes, vertical strokes, etc. The virgule, what's this? Wow, so many alternative names. This is exactly what I'm here for, baby. So division slash for division, okay. Diagonal, uncommon name. Forward slash, retronym to distinguish from backslash, following the popularization of MS-DOS, okay, sure. Fraction slash for fractions, okay. Oblique, formerly common. Scratch comma, a modern name for the virgule's historic use as a form of comma. Okay, that's interesting. So would you use this? So you could write this as like just a very large comma. That's kind of funny. A much larger comma. Okay, love it. Um, Separatrix, cool. Uh, Separating integers from decimals before the advent of the decimal point. Whoa. Shilling mark. So the long S sometimes. Okay. A development of the long S used as an abbreviation for the obsolete British shilling, and also for some modern day currencies, Kenya, Tanzania, Uganda, and Somalia. The slash is known as a shilling stroke. Slant from its shape and infrequent name, except as slants in its use to mark pronunciations off from other text, and as the original ASCII name of the character. Okay. Slash mark. Okay, so in intercal, they call it a slat. Very fun, very fun. Or maybe slack, I guess. Solidus. Stroke. He stroke she is a common British reading of he slash she. Slash has, however, become common in Britain in computing contexts, while some North American amateur radio enthusiasts employ the British stroke. Okay, well, that's interesting. So I think that pretty much answers it for me, the stroke. And then, do I want to know anything about any of this? I think I'm good. So let's close that. Okay, create a new variable called armored health. Okay, create armored health here, sure. And it should be player health times armor multiplier. Okay, so we got a 2000 there. Okay, it seems good to me. All right, so let's copy all this again. And let's go back out, and this is going to be called do some math. All right, so that's all we've got. Okay. And echo. So this one's going to be called do some math. And we got the 2000, just like here. Okay. Do some math. Okay, so cooking along, I guess. Pretty dang slowly, but whatever. Still need a whole bunch more to finish the quest. Let's keep going. Let's do some more math. Creating negative numbers in Python works the way you would probably expect. Just add a minus sign in front of a number. So my negative number equals -1. Hooray! So when our hero, okay, fun fact, computers can do math on really big numbers very quickly. That's fun. Yeah, sure. So when our hero walks through poison, their health should be reduced. Right now, the hero is gaining 10 health instead of losing 10 health. Change the poison damage variable to be negative. All right, fine by me, baby. So we'll just put the minus there, and it turns to 90, so that's fine. Let's put this into our project or whatever we want to call it. I don't know, like, this really is kind of cheating, like I'm just copying. Yeah, whatever. I'm just going to keep going. It's cheating that we're like just copying everything that they've done here into just a C++ basically version, but it's fine. So, okay, so do some more math. Do some more math. Okay. Paste that there. And this should be int. Be int. Okay. Some more math. 90. Yep. Do some more math. Okay, let's jump into the next, I guess. Okay, so we got that done. All right, comments. Comments don't run like code. They are ignored by the computer. Comments are useful for adding reminders or explaining what a piece of code does in plain English. All right. So single line comment with a hash, right? Multiple. Okay. Speed is a variable describing how fast your player moves. Multi-line comments, aka doc strings, you can use triple quotes to start and end multi-line comments as well. All right, so we know, of course, in C++ we have to use a double slash here instead, and here we use a slash star, and here we use a star slash. So pretty similar, just, you just have to kind of know that some things are different. Let's look up real quick. So in CPP reference, so if we're on this reference site and we want to know about like basic comments, excuse me, basic concepts like comments, then we look here and we see an example where okay, so we use double slash for one line, and we use this style for multiple lines. We can't make this type of comment nested. All right, so that's fine. So yeah, line number 1 in the code was meant to be a comment, but the developer forgot to use the right syntax with a hash. Fix the bug by commenting out the first line of code. Okay. Okay, so it says scimitar. I mean, oh, achievement earned for completing 15 exercises. Let's take a look. 75.07% of students have earned this achievement. Okay, so that's kind of interesting, right? Like, I mean, obviously, I've been spending a lot of time. I've been averaging like one exercise. I don't know. Let's see. I'm an hour and a half in, so I've been doing like 5 every 30 minutes, so 6 minutes per exercise. Obviously, these don't actually take 6 minutes per exercise if you're just doing them and submitting them instead of doing C++ and everything. But even so, like, so 25% almost of students have dropped off before reaching this point. And that's fine. Maybe you just come on, you do some exercises, you don't like it. But that's interesting to know about. All right, so let's copy this. And this one will be comments. Okay, let's paste. Oh, this one is not an int. It is a string this time. So, do we have string in IOStream? Let's see here. I believe we can include string. Let me look that one up. Okay, so we're looking at basic concepts. Standard library. C++, string, and standard string. Okay, I think that should be fine. The best sword variable holds the value of the best sword in the game. The best sword of the game is called Scimitar. That doesn't sound very exciting, but whatever. The game will probably continue to develop and will add more exciting sounding things like the Chaos Breaker or something. I don't know. All right, so let's echo. So this one will be called comments. And it says scimitar. Is that all we want? Okay, so next, let's go to, yeah, so we're done here. Let's go to the next. Oh, variable names. So variable names can't have spaces. They're continuous strings of characters. In Python, you should use snake case when creating variable names. It's become the rule of thumb for the language. Do you really have to quote rule of thumb like that? I don't know. I don't think you even... snake case, maybe, but rule of thumb? You should generally try to conform your casing and style to the conventions of whatever language you are programming in. By way of comparison, camel case is where the beginning of each new word except the first is capitalized, and Pascal case is where the beginning of every word is capitalized. To be honest, I don't remember like what is the standard for C++. It looks like we're using snake case here for like char traits, so I'm just gonna say it's snake case or basic string. Yeah. Okay, so no casing, pure insanity. Some variable here, so they just mushed the words together. Whatever, I think it can be fine. Camel case, they mushed them together, but this time they used a big V and a big H. So I guess that's better. Maybe help you read it a little bit. One thing it will do is if your editor has a spell checker, then this will help the editor. Your editor will not be able to spell check this, but if you do this, it might. And then some variable here, that's fine, and some variable here, Pascal case, they just made the S at the start big, otherwise the same as camel case. So let's say, which is valid camel case? Okay, so snake, and camel, and Pascal, and shouty case. So yeah, let's choose camel case. Oh, one sharpshooter spree. Let's take a look. So we can go ahead and claim our chest. So we're going to get some items for the first time. That's cool. So we got our first XP potion. I'm probably just going to hoard it up and not even use it. And then achievement earned. Okay, so one sharpshooter spree. So 51.36% of students have earned this achievement. Cool. I'll just hit continue. Yeah, sounds good to me, baby. So now we've got 3 gems, so we can buy something from the gem store. The only thing we can buy right now is going to be a baked salmon. So I'll go ahead and get one. Yay! Baked salmon purchased. Fun. All right, let's move on. Oh, okay. So, which is valid snake case? There we go. All right, basic variable types. In Python, there are several basic data types. String types. So strings are raw text. In coding speak, they are called strings because they are a list of characters strung together. Strings are declared in Python by using single quotes or double quotes. That said, for consistency's sake, we prefer double quotes. So in C++, you do have to use the double quotes for a string literal like this, and single quotes are used for a char literal, which can only be a single char, like a B. Anyway, so numeric types, and I don't know if that's like a hard, fast rule forever, but that's the way I learned it. I think it's a hard, fast rule forever, probably. The thing I said about C++, I mean the single and the double quotes. Anyway, so numbers aren't surrounded by quotes when created, but they can have decimals and negative signs. So integers are numbers without a decimal. Okay, so just a 5, minus 5. A float is a number with a decimal. So 5.2 or minus 5.2, sure. A Boolean or bool is a type that can only have one of 2 values, true or false. As you may have heard, computers really only use ones and zeros. These ones and zeros are just Boolean values. That's fair. That's fair. So is tall equals true, is short equals false. I don't know how fair that is, to be honest. Like the ones and zeros are usually they can be interpreted as Boolean values, but they're very often interpreted as one of these other types. So whatever. Fix the bugs in the code. Player health should be an integer, and player has magic should be a Boolean. Okay, so in this case, we listed these things as strings, and that's kind of messed up because we really just wanted it like that. Class int and class bool. Okay, so that's fine. All right, so let's copy this. Okay, so this one's a little bit interesting because now we're going to try to use some reflection in C++ to see what type. Is it reflection? Is reflection? It might not be. But yeah, regardless, we're just going to do this one. So this is basic variable types. Yeah, okay, so we'll make dir basic variable types. Basic variable types CPP. Okay, so let's paste that in there. So we still need that. So now, of course, here, here the situation is a bit different because here I just said player health equals 100, and then we discovered later that we could use a type on it, right? So if we're in like the Python console, right, and I say z equals 1, and then I say type z, I get a handy dandy class int, very fun, right? So we could say z equals this, and we're like, oh, what is this? Type z again, and it's a list now, right? So, I mean, it's whatever. And then what if we put these guys? Do we get... I think it's just int in this case, right? But if we put a comma here, we can make it into a tuple. I think that's enough there for now. Yeah. But yeah, basically, so here we just made an assignment, and then a type came out. In C++, we are required to say here at the start of the line what type it is that we want. So that's a little bit different compared to Python. All right, so... Okay, now this is where it's going to get a little bit more interesting, I guess. Oh, excuse me. My goodness. Because now we want to do something to say, like, what type is a variable in C++. Okay, so let's say... See, I don't actually know how to do this, so let's take a look. C++, get type of variable, I guess. It's something, it might be considered reflection, but let's see what this says. So I have int a equals 12, C out, and then type of a. So I guess the question here is, how do I implement a type of function that would do this for me? So so it says update to a very old question, and then So the accepted and good answer is to use type ID and then do name. Okay. Well, if that's an accepted good answer, then let's just start by doing that. So in fact, I am going to say, let's include string, maybe, but let's just create a helper function for us. So int type, wait, no, actually, I'm not sure what that would be. Let's take a look. So here, we are going to go type Okay, so they said to do type ID and then to call dot name. You need to include type info. Okay, so let's do that. Is that good? Okay, cool. And then same thing here. Okay, so bool player has magic equals true, int player health equals 100. This one is called basic variable types. And so it says an I and a B. Interesting. So why just I and B? Here, let me see here. I have a hunch that this is going to help us. Okay, so I said type ID, player health, name. So what if I go player health type equals type ID, player health, name. So it says you need to include type info, but I did. Use of undeclared identifier player health type. Okay, so if I try this again, will it tell me what we need? Did you mean player health? Okay, that's not going to help me. Let's look at type info, type ID then. Type ID operator. All right, type ID expression, you put some type into there, okay. And what about so when we get a type ID, we get a type info, is that this? Name. So this one used boost core to apparently demangle a name. Interesting. So why did we have to do that? Some implementations produce a human readable type name. Others, most notably GCC and Clang, return the mangled name. Oh my goodness, really? So that's what I got? Okay. So interesting. Type ID, and then what's this about mangling a name? Mangled name of the type. Let's see, simple forms of type structure such as reference and pointer types are encoded with a single character prefix. Okay. Uh-oh. Int pointer volatile const restrict var has mangled type name u4 var vkp. Okay, well. Well. But in any case, the I apparently refers to the fact that it's an int. So let me go back then. So I guess I don't want to try to mess with this unless I want to just say that this is a string. Now is it fine? Yeah, so player health is A/N/I. Player has magic is A/N/B. All right, that's fine, I guess. So I and B are, I guess, the short versions of int and bool. Yeah, so far so good. So I'll get rid of that. And this is, okay, so after I edited, it's still saying use of undeclared identifier C out. So clearly I should update my Vim settings for C++. Because that's not, like, it shouldn't be saying that, right? Because when oh, here, let's say Vim C++ LSP for G++. If I'm using G++, then let's find a LSP that is for that. Clang D, well, Clang D is what's already happening, but it doesn't seem to be working right? Because it's saying unidentified, or excuse me, undeclared identifier. But it's not going to say anything about that if I compile, right? So let's see. Do I want to do any of this? Like, the Clang D is already apparently set up, I guess. But it's not set up correctly. Is any of this going to help address that? It doesn't really look like it. Use tab. Okay. I don't really know how to fix that right now. Obviously. Obviously. Let's go to the next one. All right. So we're good here. Let's go to the next. Okay, F strings in Python. You can create, look how quickly we level up at these low levels. We're already up to level 8, having hardly done anything, really. Okay, so F strings in Python. You can create a string with dynamic values by using F strings in Python. It's a beautiful syntax that I wish more programming languages used. All right, so I've been just sort of mashing things together using the cout like stream operator or whatever they call it. But let's try and do a little bit better this next time. In fact, let's just look it up right now. C++ string interpolation. Let's see what options it says are available. String interpolation. So in C, we can do some kind of a printf. Here's the example with Python. They just called format on it, sure. We can do this, so that's fun. So this one says they used standard format. Ooh, this looks nice, right? This looks great to me. I am fine with that. Although Python's honestly is still a bit nicer, but this is very nice. This looks very nice. Okay, so That's what we're going to do. All right, so yeah, it's a beautiful syntax. You just put an F at the front, and then you can just put the variable right into there. You can put expressions into there, and that's great. The opening quotes must be preceded by the letter F, and any variables within curly brackets have their values interpolated, injected into the string, right? And it says variables, but it can be like other expressions and things. Okay, so fix the bug on line 7. Okay, so it says name is a race who is age years old. Okay, so if we run it like that, then that's what it says. But of course, we know that we can just say name. Okay. Oh, we need to put an F though. Hey, that's nice, right? Syntax highlighting comes online. We say race, sure. And we say age. And now we run it and it puts in the values. Isn't that cool? Special Ballast says cheap viewers on streamboo.com remove the space. Thanks, Special Ballast. That sounds good to me, baby. All right. Okay, so this is fine. So now if we just submit, then it says good. So yeah, replace name with the value of the name, race, age. Do not hard code the values into the string. So what would that be? So hard code the values into the string would be like if we did just put, what is it? Jarl? Jarl is a dwarf. And then just put 37. All right, all right. So we could do that, but no, we want to do this way. This is much nicer. Problem with hard coding is that it doesn't work with values that change. What if we had multiple characters, right? So we could totally like just, let's say that we just copied basically everything. And so now we could change the name to somebody else, right? Thorin Oakenshield. What's Thorin Oakenshield's age supposed to be? I think it's like in the hundreds, right? And let's say he's a badass dwarf, maybe. Something like that. And now we print it, Thorin Oakenshield, and it's the same thing here, right? And in fact, we could put, we could just say def, well, actually, hold on. Let's just say print print character, I guess, equals lambda. Does a lambda have to take something, or can you just say this? Can that work? I don't even know. Yeah, apparently so. So then we get rid of that. That's a little nicer. Print character. So then we can just print character again. And then again, if we just copy, and then we can have another one, Bomber. And I think he's maybe even older. And Jolly, maybe. And so something like that. And yeah. But let's reset it back to how it was. Sure. You cannot earn any previously claimed rewards, and this will overwrite any code you may have written. Sure. Okay, so again, let's just review how we do it. So we just say, first we put F, and then we say name, age. No, that's not age, that's race. Race and... Okay, tip. Punctuation matters. Make sure your output matches the expected output exactly. But yeah, we're already good there. So let's copy this, and we're going to use the format that we have in C++. So this one is called f-strings. I'm just going to call it string interpolation. And we'll go, just paste that. So we'll come here and say include IOStream. Oh my goodness. Do I have caps on? IOStream. Okay. And we'll say string. We'll say int. And we'll say this one is, I guess, a string too. Okay, so here let's do this. We'll say string message equals, and then we'll call the format, right? And we'll put 0 is a 1 who is 2 years old, right? And then we'll put name, race, age. And then here, won't even do that. We'll just say cout message, like that. Probably. But then, do we need to include something for format? What did it say? Use standard format. Defined in header format. Okay, works for me, baby. Okay, so now if we echo this, this one is going to be called string interpolation. And we'll say chmod. No such file or directory. Okay, never mind. So it said defined in header format since C++20. Uh-oh. Am I using an older version? Standard library header format C++20. Okay. Yeah, let's go. G++ help. We already kind of did this, right? Display target specific. Compiler version information. Let's take a look. Okay, G++. 11.4.0. It says 2021. So let's say G++ use. Yeah, let's do that. So it says since GCC 8. Okay, well this says 11. So enable C++20, add the command line parameter. Okay, sounds helpful to me, baby. Let's see what we get. So let's put that parameter in here somewhere. Is that all we need? Nope. No such file. Okay, so standard equals C++20. Okay, so I put dash O out dash standard equals C++ 20. So does it have standard here? Dash std equals standard. Assume that the input sources are for standard. Okay, so why do I not get format? Darn it. Part of the format library. Let's take a look. Formatting library. So they said hash include format. Okay, cool. But no luck. Yep, this is exactly the sort of thing need to be able to know how to do. Actually, this feels like kind of a good time for me to quickly take a short break. Pretty short, pretty short. It might be close to 5 minutes, actually. But actually, I'm going to go ahead and take a break right now. BRB. BRB in 5 minutes. I'm going to grab my keys here. All right. All right. So let's see. So we thought that the header format should have been there, or I did, but it apparently wasn't. So let's see. So it says, what did it say again? Format, no such file or directory. Okay. So C++ header file, no such file or directory. Okay, so we had a C file. I mean, yeah, sure, the message is clear. I just want to know, like, what do we typically do about it? Yeah, the message is 100% clear, yeah. Let's see what this one says. Visual GDB, nice. Okay, so this is totally Windows, Microsoft stuff, but, you know, maybe it will help us. Automatic troubleshooting, manual troubleshooting. Like, I feel like we have to install the header file from somewhere, right? So, like, so formatting. So let's say Ubuntu install C++ format header, right? Something like that. Okay, let's see what it says. Okay, yeah, this person has exactly the same thing. So not yet included. So might be in the next release. All right. So if we can't use it in G++, yeah, so we have two different options. We can try using Clang instead, which is probably a good idea. Or we could try using a different format spec, or a different format function, I guess. Okay, so where did we get this information from in the first place? It was here, right? So somebody suggested to try using format. Somebody suggested use a string stream. And sure, that's okay. No external dependencies. Works going back to C++ 03. Reportedly quite slow. Let's see, there's a boost option. So this looks nice. Let's try using the boost option. Okay, so there's a user front end where we want to include format HPP. Okay, so here we go. One of the most highly regarded and expertly designed C++ library projects in the world. I believe it, baby. All right, so anyway, so we're going to include format HPP, I guess. All right, so let's see if it gives us any help. If we go into our file, and so we don't want this, but if we go boost slash format HPP, and then what did this other person say? So then we can use boost format. Okay, so apparently they used these overloaded like mod operators. I guess that's fine. So let's say using namespace boost, maybe. I don't know how bad that is. I'm just going to try it. So now we have to do these guys, I guess. And apparently it's 1 and 2. So 1, 2. I don't know about this. I don't know about this. I'd like to try and make it work. Okay, so then apparently we use this, it looked like. Okay. And it's an external dependency, but let's not fear external dependencies forever. Let's try using it. Okay, so unknown type name string. So let's see if it gives us, okay. Let's see if it gives us some help when we try this here. So it says no such file or directory for boost. But now if I Google this one, hopefully there's more help. Boost, no such file or directory. Okay, so where do we get it from? That's my question. Where do we get the boost from? Apt get install. Okay, I was hoping it would be something very much like this. This sounds like a winner to me, baby. Although, I mean, kinda. It's pretty different from like using, for example, using Python. You have like a requirements txt. In JavaScript, you have a package JSON. Right? In Java, you have your Maven or your Gradle. In C Sharp, you have your Nugget packages, right? So this, like installing it to the system, I guess, I mean, it's different. But it just means that like people are going to have to install this if they want to build the project, right? So it's kind of like there's nothing to automatically handle it. You've just got to say, oh, no such file or directory. What do I do? I guess I have to install it, which is the same thing I just did. I guess it's not a big deal. So just noticing and commenting on the fact that it's a little bit different. All right, so let's try running it again. So it says no match for operator, this like grapes thing. So string message equals format, and so then we put in a string, but it was apparently no good. So when we use this, so this is, okay, sends the arguments to an internal stream. And we can learn how to do it here. So they said format, they said writing this, and then they put that stuff in there. So, I mean, that seems, oh, wait a minute. Oh, I have this closed on the wrong place. Okay, interesting. Let's take a look again. So this should close here. Maybe that makes more sense. It says cast from pointer to smaller type. So let's try and maybe dereference it. Or always, yeah. Let's try and maybe dereference it. Let's see what it says. Okay, no match for operator star. Oh, hold on. So if that's what I need to do here, well, let's say maybe this is a pointer. Actually, no, let me see what it says here, because I don't necessarily trust my editor messages. Okay, so it does say boost basic format char. Oh, shoot. Oh. Name, race, age. And it's pointing at... So it looks like it's pointing at the last grapes before age. Is that... Have I misunderstood what's happening? Conversion from boost basic format char to non-scalar type standard string. Okay. All right, so this is learning, baby. Oh no, that's so much. That's so much. Okay, so it looks like, yeah, let's not do that. Basic string? Is that what I'm getting? I don't think that's allowed yet, but let me see what messages it says. Oh, that's so many messages. So many messages. Candidate expects 3 arguments, 1 provided. Okay, so they did 1, 2, 3, and then they put in 3 things like that. Through repeated calls to operator grapes, each of those arguments are converted to strings, who are in turn combined into 1 string according to the format string. Okay. So when you call format, where S is the format string, it constructs an object which parses the format string. You feed variables into the formatter. So here we said format, formatter. Oh, you know, that's interesting too. That's something that actually, let me see what happens when I do it that way. So format, and then what did they say? They just said FMTER. So here it says you can take the string result possibly several times. They said do all the steps at once using the string free function. Okay, so I'm going to do it like this because that's the closest to what I was trying to do at first. But oh, and then let me change that back to string. Okay, so Jarl is a dwarf who is 37 years old. Okay, so, I mean, yeah, that's the correct output. Okay, so we said IOStream string boost format, and I used both namespaces, whatever. So we said string name, int age, string race, and then I said string message equals string format, 1, 2, 3, name, race, age. Yeah, it's compared to Python, it's rather ugly-ish, but that's not uncommon with C++. And then we said a C out message end line. So I think that's how I want to do it. Yeah, I'm gonna move on for now. Maybe I'll come back to, yeah, let's just move on. I'll come back to some of these concepts, I'm sure, at some point. So this is string interpolation. All right, so let's go to whatever's next here. Okay, so this is submitted. Okay, so none type variables. So not all variables have a value. We can declare an empty variable by setting it to none. Okay, so what is none? None is a special value in Python that represents the absence of a value or a null value. It is not the same as 0, false, or an empty string, so empty equals none. The value of empty in this instance is none until we use the assignment operator equals to give it a value. None is not a specific string, so these are two different things, none and string none. Declare a variable named enemy and set it to none. Oh, isn't it happy when you have none enemies? Okay, so enemy equals none. True. Okay, so that seems fine. Wait a minute. Am I not getting XP boosts for the boss? It says it should be 41% bonus XP, but am I not opted in? I should be, I think. Nope, I don't want that. That's crazy. Oh wait, is this a different info up here? Boss events. Okay. I think it's fine. So yeah, so that's submitted just fine. Okay, so now of course in C++ we don't have none. We have like null pointer, so let's take a look. Comments, names, types, main function, functions, overloading, standard language support. So if we want null, so this is a macro in C, but in C++ we have this guy, null pointer, right? Since C++ 11. So let's use the keyword null pointer, I guess, instead of none. Is it the same thing? No, it's not the same thing, but let's just use that. Okay, so let's go out. Let me make sure my tree still looks flattish. Yeah, that looks fine. So let's go make dir, and this one is going to be called. So we don't have none type, obviously, so I'm just going to call it null pointer. And then null pointer CPP. Sure. Okay, so let's copy that. Okay. So we'll say, so can we call this like a, well, let's see. So what would the enemy be if it were not none? So we know this guy is the null pointer type, right? Where was that? Here? Standard null pointer T. And then it's, so do we have to include something for that? It's not, is it C standard def? I don't think so. I think we're fine. Oh, so C standard def is this null macro, I believe. All right, so then here, I guess I'll just say equals. Kind of silly. Um, I guess. So what do we think we are going to get? Is this going to be fine? So this one will be called null pointer. And let's see. So it says invalid operands. Oh, let's put braces around there to help it get the order of operations correct. You think that was our problem? Yeah, so it just says 1 here. Let's try just casting it to bool. Is that going to be crazy? What's it going to say? So it still says 1. So that was not pointful. I'm just going to call that good enough for that one. Let's close some of these down. All right. Okay. Let me just take a quick glance at the GitHub and see how that's going. Basics. 15 commits, that's crazy. Right, so we added null pointer in here, and we have this. All right. Okay. Let's go to the next. Okay, so as we mentioned in the last exercise, the none keyword is used to define an empty or null value, variable, or object. In Python, the none keyword is an object, which we'll cover later, and it is a data type of the class none type. Okay, so why might you use a none value to create bugs? As the default value that will be replaced later? I guess. I mean, certainly the second might make more sense. Okay, what is 40% boots aura? Is that what we're calling the... Is that this? It must be, right? Okay, cool. All right, let's go to the next. Dynamic typing. So Python is dynamically typed. Let's take a look. So static and dynamic type checking in practice. So I think what we mean by dynamic typing is pretty much just the fact that we can assign something, so z equals 1, and this is exactly what we saw before, right? So z is an int, but then we can say z equals 1, right? And now it's a string, and does the Python runtime give us a warning that, like, oh, hey, z was an int and now it's a string? No, it doesn't give us any warning. We can reassign it as we like, and it's just dynamic, right? Dynamically typed. So let's see. So is changing the type of a variable generally a good idea? No. Oh, a daily quest chest. Let's open it up, baby. All right, so that's pretty good. 11 gems. Can we buy anything with our gems? Oh, we could. We could get an armor. Let's grab it. Oh, yeah. We could get a baked salmon, but I've already got a bunch of those, so let's not worry about that. All right, so Python is dynamically typed. All this means is that a variable can store any type, and that type can change. For example, if I make a number variable, I can later change that variable to a string. So that's exactly what I did, basically, right? So it was 5, and then we changed it to string 5. So just because you can doesn't mean you should, all right? So in almost all circumstances, it's a bad idea to change the type of a variable. The proper thing to do is to just create a new one. For example, we could say speed is 5, and then we'd used a different name. Speed description equals 5. So using a different name is better, right? So, because now we don't have to worry about any confusion as to is speed an int or a string? In this case, it was one and then it was the other, but in this case, it just stays as what it was. What if it weren't dynamically typed? Languages that aren't dynamically typed are statically typed, such as Go, which you'll learn in a later course. In a statically typed language, if you try to assign a value to a variable of the wrong type, an error would crash the program. I think usually it'll catch that at compile time, but maybe not necessarily. I think usually it'll catch it at compile time if you try to do that. So it won't work, but I don't know. When you say crash the program, it makes me think that you're talking about runtime. So maybe I'm just not thinking of the same scenario they're thinking of. I don't know. But yeah, usually if you try to do this, it will catch the error at compile time. If Python were statically typed, the first example from before would crash on the second line, and the computer would give an error along the lines of, you can't assign a string value 5 to a number variable speed. Very good. All right, so let's go to the next. Okay, so this is the same thing, right? So Python is dynamic, and that's fine. That's good. Math with strings. Okay, so most of the math operators we went over earlier don't work with strings, aside from the star and addition operators. So when working with strings, the plus operator performs a concatenation. Concatenation is a fancy word that means the joining of two strings. All right, so very fun. So you should prefer string interpolation with F strings over concatenation. Cool. All right, so we said first name Lane, last name Wagner. Oh, look, they even included a space there, and then they concatenated them together. But that's a bit silly. It would be better to just use the F string, right? Notice the so full name now holds the value Lane Wagner. Notice the extra space at the end of Lane in the first name variable. That extra space is there to separate the words in the final result Lane Wagner. So we have a second player in our game. We need to tell each of our players how much health they have left. So edit line 9 to print player 1's health. You have 1200 health using string concatenation and the variables provided. Okay, so we'll say sentence start, and we will add the number, which will be player 1 health, and then we will add the sentence end. And likewise here, we will do sentence start. We'll choose player 2 this time, and sentence end. Okay, so then if we do that, then that's fine. And we can submit, and everything is happy. Oh, so the Boots aura is going down? Oh my goodness. Not enough boss participation. Look, this is getting worse. 37. Come on, man. All right, so anyway, so that's good, so we can submit that. All right, so let's copy everything again, and we will do math with strings, I guess. All right. So make dir math with strings. Conveniently, in C++, the same plus operator can be used for string concatenation exactly the same way as in Python. So let's do that. So we'll go math with strings CPP. We'll paste. And let's include our IOStream. Fix my posture a little bit. Okay, let's include our string. Let's use our namespace. let's declare our function. Okay. All right, so let's say this is a string. Let's say, can we make all of these strings? Let me see. So if I go like this, 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 this. Ah, yes. Okay, cool. All right. I can probably do the end of the line in a similar way. Here, let me just try it real quick. So if I go Control V, 3J, big A, colon, it inserted it at the ends of the lines, except not here. Anyway, I didn't need to do that. So we have some strings, and then let's see. Okay, so in this case, I just plussed them all together instead of using the left shift operator or whatever. All right. Why do I have an extra? Okay, so I guess that's it, kinda. Whoops. Okay, I guess that's fine. So let's echo. So this one is going to be called math with strings. Seems fine. All right, so let's go to the next. So this one is multivariable declaration. So we can save space. Oh, we can do this in C++ as well. It's very similar. Although I don't know if we can mix types like this in C++. I don't think it will allow that. But if they were all the same type, then I think you can declare as many as you like. But anyway, so we can save space when creating many new variables by declaring them on the same line. Now, in Python, part of the reason that this works, or basically the real way that it works, is that it makes a tuple here, and it makes a tuple here. So let's take a quick look. So if we go into Python, and let's just copy this, and say x equals, okay, so now so x, and we see that x is a tuple, right? So now if we do this, and say equals x, all right, so now sword name, sword damage, sword length. Okay, so and then x is still like this. So basically what it does when you use this assignment is it unpacks the tuple, basically. And that's all described, of course, in the documentation. Let's actually take a quick look at that one. I mean, it's common stuff to know. I think it's worth a quick look, though. Actually, documentation, docs, is it, wait. Why am I in such a weird place? Python language documentation. Is it here? Okay, yeah. So, no, not the library reference. We want the language reference. And so when we do assignment, it will unpack. Oh no, it's assignment statements. Okay, so here it is. So in the assignment statement, you have a target list on the one side, and then you have some kind of expression on the other side, either a start expression or a yield expression, I guess. So this target list could be just a target, or there might be a comma for like additional targets. So let's just see what it says. So if the target list is a single target with no trailing comma, optionally in parentheses, the object is assigned to that target. So that's what we saw when we did X here. So on the left side, the target list was just a single target. And so that's how X became a tuple. All right. But in the other case, if that's not what it is, then you could do like a starred target. Let's see. So if it's a starred target, it must be an iterable with at least as many items as there are targets in the target list minus 1. So we can probably do that, right? Just put a star on there. Let's see what it says. Starred assignment target must be in a list or tuple. Must be in a list or tuple. Okay, so if we say z equals this, then what does it say? Oh no, okay, so that's not it. So what if we do this? Okay, so now what did we get? So now X is a list of these things. All right, cool. And then if the object must be an iterable with the same number of items as there are targets in the target list. So the object is on the right side. So if we get, basically if we get the wrong number, so like when we did this, so now X is a list, not a tuple, right? It's a list. But if we do that same thing again, then it's still fine. And sword name and everything, they still come out fine. The problem is if you use the wrong number, let's say type, I don't know, then it says not enough values to unpack. So the number always has to match. All right. So that's basically that. And so that's all described here under assignment statements. So, so that's that part. So we could say it's the same thing effectively as just saying them one at a time. Sword name equals Excalibur, sword damage equals 10, sword length equals 200. Any number of variables can be declared on the same line, and variables declared on the same line should be related to one another in some way so that the code remains easy to understand. Okay, so if they're completely unrelated, then if somebody tries to read it, they might be confused, right? So we call code that's easy to understand clean code. How many variables can be declared on the same line? No limit, baby. Oh, yes. All right, let's go to the next. And what is clean code? Easy to read and understand. All right, so again, I'm going to skip the challenges for now. All right, so functions. Functions allow us to reuse and organize code. For example, say we've written some code that calculates the area of a circle. All right, so we say we're going to have a radius equals 5. We're going to have an area, so we're going to use sort of a rounded pi and radius a couple times. Sure, that works. The problem is when we want to calculate the area of more circles, each with its own radius, we could just copy the code and change the variable names like this. Okay, so in this case, the radius was 5, and we set an area 1. And in this case, the radius was 7, and we set an area 2. Sure. But we want to reuse our code, right? Yes. So we're sort of introducing new concepts one by one. So why would we want to rewrite our work? What if we wanted to calculate the area of thousands of circles, right? That's where functions help. Okay, so instead we can define a new function called area of circle using the def keyword, right? So if we legit wanted to do like thousands of circles, then we can kind of do that, right? So let's copy this. Let's say we want 3,000 circles. So let's just copy what they've done here. That's helpful for us, right? So we can do area of circle, and we can put in a 5 like they did, and so we get some area coming out, right? Is that it? Wolfram Alpha. Area of a circle with radius 5. It is right, right? Okay, so there it is, 78.5. So that's fine. So we checked it against Wolfram Alpha, the greatest calculator website. All right, so then if we want to do thousands of these, let's say from random import rand int. So we'll use rand ints, and then let's say that we want like 3,000 things. So we're gonna say z equals rand int. Let's say it's gonna be somewhere between 0 to 10 million, and that's 4 in range 3,000, right? So we want 3,000 of them. All right, so did we get that? Okay, so now let's take a look at this. It should be a whole bunch of crazy numbers, right? Okay, so that's fine. So then, if we do circles equals area of circle R for R in Z, right? And so now we got all the radii, right? And so we can do thousands of them that easily because we used a function. So that's kind of illustrating what we're talking about here, right? So we literally calculated the area of thousands of circles, and it wasn't even hard, thanks to the magic of functions. Okay, love it. All right. So the area of circle function takes one input, which is r, so that's a radius. It returns one output result, which is an area. Cool. So the body of the function is indented and contains the code that will be run when the function is called. The return keyword tells the function to return the value that follows it as the output of the function. A function can have more than one return statement. Okay, but it's important to note that if a function does have more than one return statement, like if we put another return statement here, like whatever it is, this will never happen, because once we return once, we're out of the function and nothing else after that will happen. So then why do they say that it could have more than one return statement? So that would be like if radius less than 0, return, I don't know, because if it's a negative radius, what does that even mean? And then say else, right? So now we have two return statements, but only one of the two can happen, so we can have two like that. All right. So the return keyword tells the function to return the value that follows it as the output of the function. A function can have more than one return statement, so that's what we've got here. The name of an input is called a parameter, so radius is our parameter. In this case, it is r, so r here. The value of the input is called the argument. Okay, so when we put something in here, so the sword length becomes the argument, right? And the sword length value is 1.0. So to call this function, and it says here, a callable object is an object that can accept some arguments, also called parameters, and possibly return an object. Often a tuple containing multiple objects. So this is Python. Oh, Wikibooks. Interesting. Okay. We can now pass in any number as the argument. In this case, 5. Okay. For the parameter r, and capture the output into a new variable. Okay, so we put in a 5, and then we got a 78.5. All right. 5 goes in as the input. R, the result is calculated. Oh, no, excuse me, I read that wrong. 5 goes in as the input R, then the result is calculated, and 78.5 comes out as the output. Because the function is already defined, we can use it again and again with different inputs. And so that's kind of what we did here, right? We used it 3,000 times, and it wasn't even hard, and we could totally just do it again. We can say z is some more different random numbers, and then we can say that these are the circles, and we just did it again. We got like 3,000 more circles, I mean. All right, so easy peasy. We need to calculate the size of a weapon's attack area. So with a 1.0 meter sword, for example, a player can attack in an area of 3.14 square meters around them. Very fun. You can use the area of circle function to do that calculation. Fix the bug on line 13. Oh yeah, let's reset to the way it was. Okay, cool. So on 13 it says sphere area equals 0. The sphere area variable should be set to the result of calling the area of circle function with the given sphere length as input. Okay, cool. So, I mean, really, it's literally just this same thing. And sword length becomes sphere length, right? And, I mean, I think that's it. And, I mean, that kind of illustrates, it just makes it easy, right? So, I guess that's it. Let's submit. Oh no, the boots aura is down to 32. It keeps dropping precipitously. That's crazy. All right, well, it's fine. So let's copy this again. And this one is going to be called functions. Okay, so we'll paste here. All right, so again, we're going to say include IOStream using namespace std. Okay, so now this is going to be a separate function. So I'm going to skip past this and put my int made here. All right. Oh, that's not it. There it is. Okay, so we've got that. Don't touch above, don't touch below. We just wanted to go in here. Okay, so there we go. So this is going to be a double, I guess, or a float. Let's say it's maybe a double. And then this function definition, so we do this differently. We don't say def, instead we give the type. So we want a double. And then we say what comes in here. And then this one, let's also say it's a double, sure. We don't use a colon like that. We open up a squiggly. Okay, so then here, we can declare, it's another function just like main, so we can declare variables in the same way, of course. And let's see, so I think that's pretty much it. So double area. Now, technically, we could instead just, wait a minute. We could just return this like that. That would also be totally fine. I'm gonna say let's just do it this way though. It's fine either way. Okay, so okay, let's go ahead and so that puts it everywhere, but it doesn't get, I wonder, anyway, I'm just gonna get rid of it. Okay, so we're gonna say like that. And then we can replace everything on one line as well. here. Let's replace this. Okay, so wherever we have that comma, so it's like this. Right? And then again. Okay. So is that all we need to do? I think so. Let's run it. Okay, so we're going to say echo. This one is going to be called functions. Sword length 1 meters. Oh. Oh, something different about the way the printing happens. So in Python, you can pass multiple parameters to print, and they get all printed out with spaces between. All right. Sword length 1 meters. Okay. Sword area attack 3.14 square meters. Spear length 2 meters. So it is different in that in Python it shows the 0.0 so that you know that you're dealing with a float, basically. Here it didn't do that, and I'm fine with it. I think it's fine. Yeah, okay. All right, so let's go to the next. All right, function review. So functions are tricky. Oh, interesting. So we're reviewing after just the one lesson? Okay, that's fine. I wouldn't say they're hard, but it does take a minute to get used to them. You might find yourself slowing down a bit in this chapter, and if you do, know that that's totally normal. So let's break down this function line by line so you can understand every nook and cranny of it. Okay, so it's the same thing we saw before. Let's go through the chronological explanation of what happens when the above code is executed. So 1, def area of circle R. Okay, so the area of circle function is defined for later use but not called. All right, that's important to note. It accepts a single input named R. The body of the function, pi equals 3.14 and so on, is ignored for now, right? So none of this happens until later when we call the function. All right, so radius equals 5. A new variable called radius is created, set to the value 5. 3, area of circle radius. Okay, so we kind of went to this part, and we're going to assign whatever came out to area. So the area of circle function is called with radius. In this case, 5 is the input. Finally, we jump back to the function definition. Okay, so we're back up here again. We will now start executing the body of the function, and R is set to 5. Love it. 5 because 5 ended up here where radius was. Okay. Pi equals 3.14. Sure. New variable called pi is created with a value of 3.14. Result equals pi times r. Some simple math is evaluated. 3.14 times 5 times 5 and stored in the result variable. Return result. The result variable is returned from the function as output. Okay. So that brings us back down to here, of course. Area equals area of circle radius. The return value is stored in a new variable called area, in this case 78.5. Print area, and the area value of area is printed to the console. So that was the total breakdown, the detailed breakdown of everything. So which happens first? The function was defined. Okay. Oh, achievement earned, reached level 10. Let's take a look. 50.29% of students have earned this achievement. Okay. Fine by me, baby. All right. Of the choices, which step happens last when the code is executed? Okay, so the function is defined first, called later, and then the result is calculated, and then the value is returned. Why is the variable called radius outside the function, but r inside the function? Oh no! Needlessly hard and makes me want to cry sometimes. Only the value of the variable is passed to the function. It is then assigned to a new variable called r. Oh yeah, that makes sense. All variables are called r inside functions. Oh, I should hope not. All variables are automatically shortened to one letter inside functions. That would be interesting. But no, it is because of this, of course. So, multiple parameters. Let's take a look. Functions can have multiple parameters, which is just a fancy name for quote-unquote inputs. For example, this subtract function accepts two parameters, a and b. So we subtract a, b, result equals a minus b, and we return result. Naming parameters doesn't matter as much as setting their order. The first parameter is the first value that you pass in, the second parameter is the second value that you pass in, and so on. In this example, the subtract function is called with a equals 5 and b equals 3. Okay. And so we got the result. All right, so this function accepts 4 parameters, name, age, height, and weight. Okay, so create introduction. We pass in 4 different things. Okay, that's fine. We say first part, your name is, and put a name, and you are, and we put an age. Okay. Second part, you are, and we put a height, meters tall, and weigh, and we put a weight, kilograms. Okay, so full intro equals first part plus second part, and return full intro. So it can be called like this. So we say John, 30, and then, oh, here, this is great. So they put in my name and my age, but then here we put number literals. String literals, excuse me. String literals. 1.8 and 80. So your name is John, you're 30 years old, you are 1.8 meters tall and weigh 80 kilograms. Fine, fine, fine. So we need to calculate the total damage from a combo of 3 damaging attacks. Complete the triple attack function that takes 3 numbers as its parameters, damage 1, damage 2, and damage 3, and returns the sum. The attacks, attack 1 to attack 6, are already passed to the triple attack function for you, so you do not need to use them directly in the function. So first of all, let's do what it mentioned. So we'll say return damage 1 plus damage 2 plus damage 3, right? So that's fine. And then when we run, it's like, okay, getting damage for 2, 4, and 3, 9 points of damage dealt. Okay, so that happened here. Getting damage for -1, 10, and 5, 14 points of damage dealt. Okay. I guess that's it. So we'll say, okay. Oh, a sharpshooter chest. Another one. All right. So open that up. Another XP potion. Cool. All right. What can we afford? A baked salmon? I don't need any baked salmon. So I will save these 7 gems until we can get something more interesting. All right. Okay, so that's it. So let's copy all of this. And this is going to be CPP again. Okay, so this one is called multiple parameters. Nope, not that one. All right, so I'm going to say... Okay, I'll paste this. We'll put some of these in again. Okay, so let's come down to here. Int main. Okay. Sure. Whoops. Okay, what else? So here, these are all going to become int. Whoops. Technically, we can put the semicolon everywhere all at once, right? So if we go that, and then here, okay, so is this one supposed to return an int as well? Oh, it is. So this one's an int. Okay. Okay, so these are going to be int. Now, do we have to put the variable name or the variable type before every variable? Let's quick Google that. I think that's a good thing to Google. In C++, do we have to put the variable type before each and every parameter in the function definition? So you can put just the int somewhere. So it must be for each and every, right? I think that's fine. Udacity type system. Okay, so this is fine. So we'll just put int in front of here. Okay, cool. So that should be fine. Then when we come down to here, let's go ahead and make some replaces. No. So when we have print, let's instead say cout. Okay, sure. And then wherever we have this, let's say that that is instead going to be, we still have this, but we're going to have that. Okay. Okay, so that's fine. I'm on the wrong place though. Maybe it's fine. Okay, so we'll replace that with that just on this one. Okay, so vim repeat substitution. And okay, there we go. So this one's going to be called multiple parameters. Okay, so it says getting damage for 24 and 3, 9 points of damage dealt. We want those spaces in there again. Okay, what about that's fun. Oh, I don't get that. Getting damage for 24 and 3, 9 points of damage dealt. Getting damage for minus 110 and 5, 14 points of damage dealt. So it's not minus 110. Those need to be separated out. So getting damage for minus 1, 10, and 5 with spaces in between, right? Okay, so let's just throw a space in there. Getting damage for 2, 4, and 3. 9 points of damage dealt. Getting damage for minus 1, 10, and 5. 14 points of damage dealt. Okay, better. All right, this is going pretty well, I think. Okay, so that's good. Let's git add multiple parameters. Okay, all clean. Okay, let's move on to the next here. I'm going to close these out again. All right. Printing versus returning. Some new developers get hung up on the difference between print and return. Okay, good, good, good. Let's talk about it. It can be particularly tricky when the test suite we provide prints the output of your functions to the console. This makes it seem like print and return are interchangeable, but they are not. Print. It's a function that prints a value to the console. It does not return a value, okay? Return, a keyword that ends the function execution It gives the specified value back to the caller of the function. It does not print anything to the console. Okay, cool. So printing to debug your code. So printing values and running your code in the console is a great way to debug your code. Okay, sounds good. So you can see what variables, or excuse me, you can see what values are stored in various variables, find your mistakes, and fix them. Add print statements and run your code as you go. It's a great habit to get into to make sure that each line you write is doing what you expect it to do. In the real world, it's rare to leave print statements in your code once you're done debugging. Similarly, you need to remember to remove any print statements from your code before submitting your work for review here on boot.dev because it will interfere with the test suite. Okay, cool. So, there is a problem in the getTitle function. It's supposed to calculate the title value and return it to the caller. Instead, it's barbarically printing the value to the console. Fix the function so that it returns the title value instead of printing it to the console. Okay, so is that better? Gandalf the Grey Wizard, Aragorn, son of Arathorn the Ranger. Okay, seems fair enough. That's it, right? Okay, cool. Works for me, baby. All right, so let's do this in our C++. Oh, interesting. So def test. Okay, gotcha. That's fine. Okay, let's copy. And so this one is called print verse return. Okay, let's paste that guy in there. Okay, so we'll have the title. We'll have the test, and then this part is going to be int main. Okay. So we'll run these tests. Let me just put some semicolons in here, I guess. All right, that part looks fine, I think. Okay, so then these prints will, of course, become cout. No, there we go. So print like that. Okay, better. Okay, so we know get title looks like it should be a string, right? And then what is this? Is this also a string? Looks like it. Okay. Let's put some semicolons in here. This one's also a string, if I could even spell it correctly. Okay, that looks fine. Okay, cool. I think that's fine. Let's get rid of that. And then here, let's add some. Let's add a semicolon here. And then let's go ahead and replace. So at the end, we can do that, right? Okay. String title. Okay, so then this one should be void. All right. So this one's going to be called print v return. So we couldn't do that. It says template. Let's see. Could it deduce template parameter? I have some commas in there still. Let's get rid of those commas. Is that right? There's still this one here. Is that better? I think so. Whoops. Okay. Whoops. Okay. Invalid operand types. Let's see. Test Frodo. Oh, goodness. That's crazy. First name Frodo, last name Baggins. Let me throw some extra spaces in here somewhere. First name. First name Frodo, last name Baggins, job warrior, title Frodo Baggins the warrior, Bilbo. Okay, Gandalf, Grey Wizard, okay. So that looks fine to me. Let's add. So this one is called print versus return. All right, so now I think we're good there. Let's go to the next one. Where to declare functions. So you've probably noticed that a variable needs to be declared before it's used. For example, the following doesn't work. So we can try print my name equals Lane Wagner. Okay, so it'll just say, so we won't get anything if we do that because it's not defined, right? Let's take a quick look. So if we say print my name, it just says not defined. Messed up, baby. Okay, so yeah, so it needs to be defined first. So lines of code execute in order from top to bottom, so a variable needs to be declared before it can be used. That means that if you define a function, you cannot call that function until after the definition. The main function is a convention used in many programming languages to specify the entry point of an application. By defining a single main function and only calling main at the end of the entire program, we ensure that all of our functions are defined before they're called. All right, I have to go blow my nose real quick. I'll be back. Okay. All right, so where were we? By defining a single main function and only calling main at the end of the entire program, we ensure that all of our functions are defined before they're called. All right, cool. Fantasy Quest is booting up, game is running. So that's fine, I guess. So, I mean, so this is just where to declare functions. All right, let's quick get this one done. Where to declare functions. All right. So we'll paste here. So now, I mean, it doesn't really make much sense to make this main, I don't think. Um, I think it makes more sense to do main here, and then we can call welcome over here. I guess. But the truth is, like, maybe it would illustrate the point better in a way if we defined this after, which is totally allowed, right? So we could totally get rid of this and put it down here, and that's totally valid, right? Should we do that? Sure, let's do that. So this one's called where to declare functions. Welcome was not declared in this scope. Okay, so I guess, you know, I declared confidently thinking, oh, that's totally allowed. But maybe it's not. That's totally good to know. Okay, so what's it say now? So now it's fine. Okay, that is totally good to know. So it's not hoisted. Let me put a note of that because I think that's interesting. Note that the function does not seem to be hoisted if declared after int. All right, I'm cool with that. So where to declare functions. Okay, let's go to the next. Functions must be blank before they can be blank. So they must be defined before they can be called. All right, so should we read over this next one, order of functions? All functions must be defined before they're used. And we saw just then that that is also true in C++. Apparently, I mean, here, let's just read up a little bit. Can functions be hoisted in C++? It says many C compilers have implemented this feature. traditional K and RC had this quote-unquote feature. Okay. I think this pretty much answers it well enough. Let's see, may reorder. Okay, I'm not worried about that. I'm just gonna move on. Okay. You might think this would make structuring Python code hard because the order of the functions needs to be just right. As it turns out, there's a simple trick that makes it super easy. Most Python developers solve this problem by defining all the functions in their program first, then finally calling the entry point function last. Conventionally, this entry point function is usually called main to keep things simple and consistent. If you follow this pattern, you can forget about ordering. All of the functions have been read by the Python interpreter before the first one is called. Okay, so we read this one, we read this one, we read this one, and we notice nothing has been called yet. And finally, something actually becomes called. Okay, so let's go to the next. Functions must be defined in the same order they call one another. Not true. Which is best practice to make sure you don't define functions out of order. Create an entry point function, usually called main, and call it at the end of the file. Create a function called main. Python will always call it first. Not true, but this is true in C++. Create a function called main and call it at the beginning of the file. Well, if it's at the beginning, then you don't get the benefit of it. It should be very end. Create a function called entry point. Python will always call it first. No, not true. That's crazy. We did say entry point here, but whatever. All right, so yeah, so we'll do that. Functions practice degrees. So this one is required. Looks like there's a bunch more here. I did blow my nose. All right, I'm gonna keep going about 20 more minutes. Okay, so in Fantasy Quest, as characters are running around the map, they can lose health due to heat exhaustion. The game tracks the temperature in Fahrenheit, but we need to display the temperature in Celsius for players outside the US. Okay, so here we have a conversion formula. Fine. Looks like we should probably just copy that directly into here. So let me just do it while I'm thinking about it. So C is the temperature in degrees Celsius. F is the temperature in degrees Fahrenheit. Okay, fair enough. So if we set Fahrenheit to 77, we'd use the formula like this to calculate the temperature in degrees Celsius by hand. Okay, so we put in the 77, was substituted in. Then we made a subtraction because we're following order of operations. That's fine. Then we, let's see. So we, actually, why do we do it this way? Five times 5, 25. Okay, so that's fine. So we just, what is the rule called? I don't, this is basic arithmetic. What's the rule called? It's, it's a property. Let's see. Basic arithmetic properties. Which one is it? Is it commutative? It's commutative. Commutative property, right? Nope, nope, it's not commutative. Is it associative? Maybe. Is it distributive? I don't remember what it is. For the life of me. All right. Eh, I don't know. It's kind of beside the point. It's basically what? Associative property? I don't know what it is. Okay, so we basically just moved it over. Um, then we did the division because that's easy. So sure. So just copy over the formula, let the computer replace F. Okay, so that's fine. So when we run it, we get some results, so that's cool. All right, let's copy this copy this bad boy. Oh, wait a minute, wait a minute. Have I been putting everything in introduction? I have, right? Okay, so that's crazy. I don't want everything in introduction. Oh my goodness. I want it all in basics. Yeah, no, everything should not be in introduction. Can I do MV glob? Let's take a look. So like that? No. Like this? Okay, so that's better. So now we just move main sh to okay, so we're all directories now. And is it flat? So something is missing from where to declare functions. Is that okay? We'll have to check on that. And something is missing from introduction. It says where to declare functions. Why is that? Oh, I messed it up. Okay, so let me look at it on the GitHub. Go back to here. Yeah, not everything should have been in there. Let's go back to the first. Nope, I don't understand it. Let's see. So I did welcome. I don't, man, it's been like 3+ hours and I don't remember why I used the term introduction. Oh, that was the chapter name. Well, honestly, that makes a lot more sense. And then at some point I decided I didn't want to do the chapter names, but honestly, I do want to do the chapter names actually. So so the other chapters should be variables and functions, right? Okay, so variables already exists. Okay, so, and functions are just, okay. Whoops. So let's go make dir functions functions, because is that what it is? Yeah. So then okay, so better. Okay, so what was supposed to be an introduction? I had welcome, we had first bug, right? So then what else? Multiple instructions. Okay. Syntax errors, was that one? Okay, what was basic variable types? That's in variables, presumably, right? Yeah. Nope, 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 nope. Okay. Null pointer, that was in here as well, right? Yeah. Okay, print versus return is in functions, of course. Okay, math with strings, is that variables? Um, Comments, is that introduction? Is it variables? Okay, console, what was console? Is that introduction? Okay, variables vary, that's variables, right? Okay, what is, let's see, do some more math, that's probably functions. Degrees. Where to declare functions, that's functions. Multiple parameters, that's functions. Okay. Welcome is introduction. String interpolation, is that introduction? Is that variables? That was, what was it? F strings, right? Okay. Do some math and do some more math. Is that... Yeah, right here. Okay. Okay, and then what is code? Is that introduction? What is code? Okay, how's the tree look now, baby? All right. So we have functions, which we've just got 4 so far. Where to declare functions? Did I run it? I did, right? So it's missing some stuff for whatever reason. So introduction. Uh-oh. There's some stuff in introduction that doesn't belong. This one belongs to where to declare functions. Okay, so okay, I think, does that fix the tree? All right, I'm just about done for the night. Okay, so this looks pretty good, I think. Okay, I'm gonna commit those changes. Fix directory structure to include nested chapters. Okay, that's fine, I think. So let's see how it looks here. So it just says renamed without changes, so that's good. Good, 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 good. All right, so now where are we supposed to be at? Functions. So did we finish degrees? No, not yet. Let me try and finish it before I end for the night. So we're supposed to go to functions and make dir degrees. Paste that. Okay, so this one will be double, I guess, right? When we run this, what do we get? Doubles. Okay. Apparently it passes in ints though, so this one should be int apparently. We'll see how that goes. Okay. So here we pass in an int. round. Oh, interesting. C++ round double. Okay, hit me with it. I don't, yeah, okay, so we can use round. But what does round do? C++ standard round. So round, you pass in a double and get back a double. That sounds good. Nearest integer value. Okay, okay, okay. And so that's why they're talking about math, because, okay, that's fine. So here we will include whatever it is that we're supposed to have, which is CMath. And let's see. Is that looking better a little bit? Okay, double to Celsius, int f. Result of integer division used in a floating point context. Okay. Right. So I'm just going to say that it's going to be like this. And then what else do we need to say here? So when we do round, that should be defined in CMath. So I think that should be okay. But then we're going to multiply let me see what it says. So this one's going to be called degrees, and yeah, I want to log off here as soon as this is done. I think it's just about done. All right, chmod. It's oh, okay, it came out. Let me just put some spaces in there. 3778, is that good? Yep. 3111, sure. 40 and 4444. I dig it. Let me just put some spaces in there. All right, 3778. Okay, I think that's good. That looks fine to me. So I'm going to call it a night there. I'm pretty happy with this whole concept, honestly. Yeah, I like the idea. I do think I like for a beginner programmer, I generally think I like the idea of C++ maybe a little bit better. Like C++ is kind of what I started with in high school before I messed with Game Maker. But I mean, it's not like I'm a success story, but I mean, I don't know. I'm gonna call it a night there. So long. Have a